Welcome back to the episode 5.17 of our video course Parallel Programming and Optimization with Intel Xeon Phi coprocessors. In this episode, we'll mention the optimization opportunities for distributed memory applications that use Intel MPI and Intel Xeon Phi coprocessors.
When Intel Xeon Phi coprocessors are used in distributed memory applications with MPI, there are two options for using them. The first method is to put MPI processes on hosts and use the offload model to communicate with coprocessors. In this case, communication over MPI is no different from communication in CPU-only clusters, so we will not focus on this method. The second method is to put MPI processes directly on Xeon Phi coprocessors. In this case, it is possible to perform peer-to-peer and collective communication between coprocessors in different machines, and it is important to understand the consequences of such usage model. When Xeon Phi coprocessors communicate with each other, they access the network through the PCI Express interconnects. This is the only connector on Xeon Phi cards, and there are no Ethernet or InfiniBand ports on Xeon Phi coprocessors. The MPSS stack can virtualize Ethernet or InfiniBand network in the operating system running on Xeon Phi. This makes networking transparent to applications. In other words, your application does not know that its MPI calls will send data across the PCI Express bus and then across another network. Even though communication between coprocessors may work seamlessly, you as the programmer must make sure that MPI is using the InfiniBand fabric if it is available. The key environment variable for selecting communication fabric between coprocessors in Intel MPI is IMPI fabrics, and you can use the variable IMPI debug to diagnose the fabric usage. See the Colfax research publication about this at the URL xeonphi.com/papers/p2p. Another important consideration is that when you use several Intel Xeon Phi coprocessors per node, they all share the InfiniBand cards available in the host. As a consequence, for collective communication with all-to-all patterns, you may want to choose MPI with offload over just native MPI if communication is significant. That is because with offload you have as many MPI communication endpoints as you have compute nodes, whereas with native model you have as many endpoints as Xeon Phi coprocessors, but the same amount of networking hardware. For a case study illustrating the importance of this choice, see presentation available at the URL xeonphi.com/papers/sc14.
If you have any questions, leave them in the comment section below the video. Thank you for tuning in, and I hope to see you in the next episode.